So we look at question P5 from 2018 November. So the question states calcium oxide is produced by heating limestone. Following the reaction below, calcium oxide, okay, when it decomposed by heat, it forms calcium oxide plus carbon dioxide. Okay, then we are told to determine the relative formula mass of calcium carbonate. So when you're determining the relative formula mass, RFM, okay, RFM, we get the given compound, okay, calcium carbonate, okay, like this. So we look at the mass number for carbon, calcium, and then carbon, then also oxygen, okay. So calcium has the mass number of 40 on the periodic table. If you check, calcium has the mass number of 40. Okay, so we get that mass number, okay. So we say 40 times the calcium's present is 1. So what you have is 40. Okay, and then carbon, the mass number for carbon is 12. So when you say 12 times 1, we are getting 12. Then oxygen is 16. The mass number of oxygen is 16. So when you say 16 times the molecules present, there are 3. So when you say 16 times 3, you get 48. Okay, so when you add everything, 48 plus 12, we are getting 60 plus 40, we are getting 100. So we get 100. So 100 is the actual relative formula mass, okay? So we can just write 100, okay? And then we look at the second part. So the second part is on theoretical yield. So we are given determine the mass of calcium oxide produced if 400 grams of calcium carbonate is decomposed fully, just like the previous video, okay? Okay, so if you look at the previous question, we were looking at the calculation for theoretical yield. So we look at the given equation. So what are we given for calcium carbonate? So we are given 400 grams of calcium carbonate. So here we are given 400 grams. And then we are told to find the mass of this unknown substance, which is calcium oxide. So we are told to determine the mass of calcium oxide. So to do that, we use this formula, mass over molar mass. Okay, let me write it from this side. So we state mass over molar mass, and then equal to mass over molar mass in this form. Okay, then we see exactly what this side is for. So the left side, on the left side, we are given the compound calcium carbonate. So we see what we are given for it. We are given the mass. It has the mass of 400 grams. So its mass is 400 grams. Okay, we can state 400 grams, okay, of calcium carbonate. Then we see what we are given as its molar mass. So the molar mass is the same as relative formula mass, but the difference is it is measured in grams per mole. So we can just take this value here. We can just get what we have found already, which is the relative formula mass. So we just do the same procedure. So we have 100 grams. So you can say 100 grams. Now we just add the units. It will be 100 grams per mole. Okay, 100 grams per mole. So you can redo this. Okay, you can redo this method, or you can just get the value direct. So out of time, you can just get the value direct. Okay, so here you add the units, grams per mole. So here we say equal to, and then to the other side there, we don't have the mass, okay, but we can find the mister. So we find the mister of calcium oxide, like that, okay. So the mass number for calcium is 14, and then the mass number for oxygen is 16. So when you say 16 times 1, and then here also 40 times 1. Okay, so what we are getting here is 14, and then there we are getting 16. So when you add the 16 plus 40, we are getting 56 grams per mole. That's what we get, okay? So upon getting 56 grams per mole, we can get this value and then apply it in the formula, okay? So we can apply 56 grams per mole from here, 56 grams per mole, like that. And then what we do, we cross multiply. So when we cross multiply, we can state 400 grams times 56. Okay, so when you say 400 grams times 56, I'm getting 2,000, okay, 220 or 22,400. That's what I'm getting, okay. grams. When grams and grams go, what remains is moles. Okay, so let me take off the grams. Okay, so here I will have grams per mole. Okay, grams per mole, like that. And then to this side, when we say mass times the 100 grams per mole, we are getting 100 grams per mole, and then m. Okay, that's what we are having. Okay, so we divide both side by 100 grams per mole, so 100 grams per mole here. Okay, and then also this side by 100 grams per mole, by 100 grams per mole, like that. So we can cancel out this one, that one goes, and then what we are remaining with is mass. So mass would be equal to, in here we can cancel the zeros, those zeros and those zeros of 100 will go, and then moles and moles will cancel. Okay, so we are remaining with the grams. Okay, so we remain with grams. So what we remain with is 224, okay, grams of calcium oxide. So that's what we are having. Okay, so upon having this value, we can now go on to the other question. So the other question was on the uses. Okay, see, give one natural and one artificial use of the gas produced in the reaction above. So what is the gas produced in the reaction above? So the gas produced in the above reaction, we have carbon dioxide. So carbon dioxide is the gas that is produced, okay, when the calcium carbonate decomposes. So we have carbon dioxide. So carbon dioxide has natural uses. So carbon dioxide, we can say it is used for photosynthesis. Okay, so we can say used for photosynthesis. Okay, I hope we can remember photosynthesis during the day usually uses carbon dioxide. Okay, and then use it, take out oxygen. So this is the natural use of carbon dioxide. And then also artificial use, used in making carbonated drinks. Okay, used in making carbonated drinks. Okay, like Coca-Cola and so forth. Okay, and then also we can say used for fermentation. Okay, that is optional. Okay, we can say used in fermentation. Okay, we can even say that. Okay, so these are some of the uses of these are some of the artificial use, and then also the natural use of carbon dioxide.